To go along with our agents installed in every single node, we also have to consider the role of a Puppet Master infrastructure. The role of a Puppet Master is to serve catalogs to individual Puppet agents. What that means is that a Puppet Master maintains the defined configuration of every node in the infrastructure. A Puppet Master will have a copy of the module files, the manifest files, and essentially the Puppet code that identifies the configuration of every single node or server in the entire infrastructure. When a Puppet agent contacts a master, the master determines what software and what configuration should be applied to the agent and configures a very large catalog file that is sent to the agent for processing. The agent will take the catalog file and install and configure software on the local nodes. The Puppet Master is also the repository of information about the entire environment. So a Puppet Master will host the Puppet code that we'll be writing in terms of manifests and modules, and it will also hold data related to these environments. So individual configuration items will be stored and served from the Puppet Master. And these can be files. It can even be pieces of data, such as server addresses or authentication credentials. So the Puppet Master infrastructure becomes a parent repository of nearly every bit of information about the environment. The Puppet Master is responsible for compiling catalogs for every node in the environment. The Puppet Master is also responsible for taking all of that information and compiling them into catalogs. So when a Puppet Master creates a catalog, it can be a very computationally intensive process to match information, to match catalogs and nodes and apply them into a set of instructions for agents. So the key to the Puppet Master scalability is its ability to compile and serve catalogs for the entire infrastructure. The Puppet Master is also responsible for receiving reports from every single agent on runs of both the factor process, which gathers information about the environments, and also the Puppet reporting process, which gathers information about the end state and the result of Puppet agent runs. In many cases, the Puppet Master can store that information on a local disk, or it can even forward that information onto a reporting system such as PuppetDB for later querying and consolidation. When setting up the Puppet Master, we have to note that a Puppet Master is essentially a Ruby application. A Ruby application that can be run in either a Puppet Master mode, operating as an individual process using the Ruby runtime, or it can be executed within a web server runtime using a tool called Ruby Passenger. When using a Puppet Master, you might consider the Puppet Master service, the single Ruby thread, to be a development environment, as it typically tends not to be very scalable for most uses. Instead, you'll want to install a Puppet Master using a Ruby Passenger runtime. That will allow the Puppet Master to be a little more scalable and also have all of the features of a full-fledged web server rather than the individual server node of a Puppet Master. I should also note that at this time the Puppet Master is being deprecated in favor of a new technology. The Puppet Master infrastructure will still be valid, and the Ruby application will still perform most of the actions that you'll use in your Puppet infrastructure. To find out a little bit more information about how to configure a Puppet Master in your local environment, again, consult docs.puppetlabs.com and specifically take a look at the post-install steps after installing Puppet. The Puppet Master process can be configured to serve catalogs to individual agents in the same type of installation environment as we installed agents. Now, I mentioned the deprecation of the Puppet Master. The Puppet Master is being deprecated in favor of a product called Puppet Server. The Puppet Server is geared to be a drop-in replacement for the Ruby-based Puppet Master. The big difference in the Puppet Server is that the Puppet Server is based on a technology stack that uses the Java Virtual Machine. Specifically, the Java Virtual Machine technologies of Clojure to operate the Puppet Server, and JRuby, which will allow you to use the Ruby-based modules and applications that have already been developed to support Puppet agents and Puppet Masters. So Ruby will remain the scripting language of the Puppet environment, while the server itself will run on top of the JVM, and we'll be able to use the threading and performance capabilities of the Java Virtual Machine. This means that a Puppet server will be more scalable and use less resources than current Puppet Master environments. This has been something of a sticking point for Puppet Master environments, is that scaling Puppet Masters can be a fairly difficult task. The Puppet server will use a slightly different technology stack to allow for more scalable systems, and will also have more tools for monitoring and scaling the infrastructure itself. You can find a bit more information on the Puppet server by visiting its development page at GitHub. So github.com/puppetlabs puppet-server. On that page, you'll find a little bit of information about the server itself, the status of the server at this present point in time, and some documentation on how to use the server and some of the differences between operating the Ruby-based Puppet Master and the Java Virtual Machine-based Puppet server.